Okay, this is a pretty interesting problem. Here's the original function right here. The problem doesn't state whether a is positive or negative, but it makes a difference to the problem. If I share my screen, and go to Desmos, there's a graph of the function with different values of a. Say that a can go from negative 1,000 to 3,000. If I shift the value of a positive direction, you can see right now at that value of a, the minimum value for y is 4.092. So we have to get up pretty high before we reach a value of 8. But if I go in the negative direction, everything turns upside down. So we're going to assume for this problem that a is positive. Okay, so to find the places where the absolute max and min might occur, let's find f prime. Notice I rewrote this way. The negative 1 for the denominator is an exponent. So applying the power rule, opposite of a times that denominator raised to the minus 2 times the derivative of the inside. I meant to put brackets here. So the derivative of the inside is 2x. Think of this as x to the 1/2, so 1/2 times negative 8 times x to the minus 1/2. And the derivative of the 60 is 0. And so this part right here can be written as 2x minus 4 over the square root of x. And I have the minus sitting out front. But the point is, when does this equal 0? Well, it equals 0 if I divide both sides by the opposite of a. I still get this expression equals 0. If I set 2x equal to 4 over the square root of x, multiply both sides by x to the 1/2, and then divide both sides by 2, I get this, and it looks like x is the cube root of 4, or 4 to the 1/3. Okay, so those are the numbers that you have to test. The endpoints, the critical number, there's 3 of them to test. And if I find f of those values, I get expressions that look like this. A over 60, a over this, which down here I have some little scrap paper work where I wrote these as base 2. The point is that the bigger the denominator, the smaller the y value. So to answer question B, when does this reach an absolute minimum? It reaches that absolute minimum at this biggest denominator, so f of 21. And that's what we saw on this graph over here. Absolute minimum occurs when x is 21. This is the smallest denominator here because 2 to the 4/3 minus 2 to the 10/3 is negative, and then negative added to 60, that's going to be a smaller denominator than the 60. So that's why the absolute maximum occurs where the smallest denominator happens. Now, how do we, if we're assuming that the absolute minimum is 8, how do we find the value of a? Well, we just say that f of 21 is going to give us our minimum value because that's the biggest denominator. If I take 8 times whatever that function value is at 21, I'll get the value of a that's required because I want this to be an 8. And here I use Desmos to get that. And there's the value of A. That gives us an 8 for the absolute minimum. And by the way, here's the absolute maximum. That's the answer to part D. And that would be finding f of the 4 to the 1/3 when A is this value. Okay, it requires a calculator, I think, to figure that out. There you go. Hope that helped. If you have any questions, post a comment.